You know as good as well as I do that this is where we ended the last video. So we left off with this example problem, and I told you the problem here is to actually take the name and convert it to a structure so that way we can make a product from the reaction. So can you use the rules of ketones and aldehyde nomenclature in order to make or draw the reagent in order to make the product? All right, so let's see how well you did your job, shall we? All right, so cyclopentanone. All right, so cyclopent means a circle with a 5-membered carbon ring, and one is a ketone. So the ketone can be anywhere it wants to be. It doesn't matter, folks. That's the beauty, again, of organic. So that is okay, and to the right is okay, and to the left is okay, and to the bottom is okay, and to the bottom right is okay. It doesn't really matter where you put it. So cyclopentanone with ethyl amine. All right, so ethyl is CH3CH2, and the amine is NH2. So we want to know what type of product is going to be formed from this reaction. All right, well, this is not a problem. This nitrogen brings all of the alkyl groups to the party. That's what we're looking at here. So here is our cyclopentane and a double bond. That nitrogen has came in and off the oxygen goes, and nitrogen brings the buddies to the club. So what nitrogen brings is a CH2 and a CH3. All of the other hydrogens go bye-bye. Away they go, and those two hydrogens and that oxygen make sweet organic love to make a water product. All right, so here we have a product. That product has a nitrogen. That nitrogen has 3 bonds, and that's exactly what it wants. So this, ladies and gentlemen, is the formation of a amine product. All right, so the reason for that is that this was a primary amine that reacted with those top 2 carbonyls. All right, so now the next one, cyclopentanone. So this is the same exact thing, cyclopentanone, so we'll draw it the same way. And with this one, it's diethylamine. All right, so diethyl means 2 ethyl groups. All right, so I'm just going to draw it this way just so that we can keep it consistent. So that nitrogen has 2 ethyl groups on it, because that's what the name says, diethyl, and then the amine group. So nitrogen has 2 bonds, and there is my third one. So it's an NH. Okay, so this one's a little different, and the reason, we'll see. Here is my cyclopentanone, and that double bond is replaced with a nitrogen instead of an oxygen for the same reason as up above, and that nitrogen brings the buddies to the club. All right, so what does it bring? It brings a CH2 and a CH3, and a CH2 and a CH3. So one of those hydrogens have disappeared, and that oxygen has disappeared. But the problem is that this nitrogen, as it's written right now, has 4 bonds. Those 4 bonds cannot happen. So we're going to have to get rid of one of those double bonds, and it will shift it inward, and this makes an enamine because it shifted it inward. So this is the product that we are left with from that particular reaction. So this is an enamine because this is a secondary amine that we have reacted with that ketone or aldehyde. Either one of those would have worked the same. All right, so the next one, cyclopentanone with hexyl amine. All right, so goodness gracious, cyclopentanone. If I could not draw that, then I was in a world of hurt and trouble in this example problem. All right, so here's this 5-membered ring with the double bond O, and we are reacting this with hexyl amine. So hexyl, all right, 1 and a 2 and a 3 and a 4 and a 5 and a 6. So there's 6 carbons. And amine, so hexyl amine, that is an NH2 that happens at the end. All right, so that 6-membered ring and the NH2 is going to react with the ketone yet again. So that double bond is not a double bond O, but a double bond N. And that nitrogen brings the buddies to the club, and that buddy Well, we've got 1 carbon and 2 carbon and 3 carbon and 4 carbon and 5 carbon and 6 carbon. So there we go, folks. This nitrogen's perfectly okay. It has a double bond and 1 bond to another carbon, so a total of 3. Therefore, that double bond in is perfectly fine. This has made another amine product. Notice that we've not named them. We're not going to name them. We're just going to classify those functional groups. So an amine product has been formed again, and that's because this is a primary amine, just like our very first example was. All right, so finally, the 4th one was cyclopentanone. Oh, goodness. All right, so there's cyclopentanone. I can draw it in my sleep at this point. And then we're going to react that with cyclohexyl amine. All right, so cyclohexyl amine, what does that mean? Well, that means that I have an amine group, and off of that is a cyclohexane. So that's what that thing looks like, all right? Now, this is a little different than one of the previous examples that we did, and the reason is because the nitrogen is attached to the cyclohexyl piece. All right, so with that said, let's form our product. So here we have cyclopentanone, and then I'm going to that oxygen away, and we're going to replace that with a nitrogen. And that nitrogen is going to bring the buddies to the club. And those buddies, in this case, is a big, whopping cyclohexane ring. All right, well, if I take a look at that, this nitrogen is attached to only 1 carbon-containing group, and therefore that is a primary. I know that primary amines, when the type 2 reactions hit, will form an amine because that nitrogen is okay with the double bond that's present here. All right, so there's the product for that reaction, just like all of the others that we've talked about from up above. Now, the difference here, folks, one of those previous examples was a nitrogen that was part of a ring, and that might be what you were thinking about here with this number 4. The difference is that nitrogen is in the ring, and there is a group to the left that it's connected to and a group to the right that it's connected to. So in that case, that was a secondary amine group, and that secondary group behaved a little differently because it formed an enamine instead of an amine. All right? So that was just a kind of a recap of what we saw in a previous example problems. All right, now here's the story. Now that we've gotten comfortable with these amines, you need to understand that there are other ways that we can get kind of to what we were doing. And these other reagents are going to come up to bat. So in every single case so far, we have used an amine, right? We have used an amine, and they have been primary or they have been secondary mainly in order for these reactions to go forward. But there are a couple of other alternatives that are out there that I could use that are nitrogen-containing species. So one of the first ones that we might see in this general reaction area is something called hydroxyl amine, all right? So hydroxyl amine can also be used, and these can react with type 2 carbonyls in order to make products, and we'll see what hydroxyl amines will actually do. All right, number 2, well, we can have something called 2,4-di-nitro phenol Hydrazine. Okay, now hydrazine's already lost me. I was doing good. 2,4-di-nitrophenol. All of those are words that kind of make me trigger a little bit. But the hydrazine is something completely different. What on earth is that? Well, we'll figure it out when we see it. And number 3 is something called a semi-carbazide. All right, so semi-carbazide. And they can react with carbonyls just as well as the amines can as well. What we do is that we call these the amine derivatives. And the reason is because we are going to start forming something that looks like an amine, but not quite like an amine. And you're going to see that in some of the products. So because of that, it's related. It's not exactly the same. So we call it a derivative because it's kind of a derivative form of it. You know, it's kind of like Madonna talking about Lady Gaga. It's just a derivative form of me. I mean, that's what she said in an interview. So that's how you need to look at these particular types of functional groups. Now, whether or not you like Madonna and Lady Gaga, they both might be derivatives to you, and if so, then so be it. But, you know, there's kind of the diva reaction scheme, if you that's what you want to call it, that happens in our entertainment industry. All right, so let's take a look at the very first example. Let's take a look at something like benzene, right? I don't want to ever forget about those. And this is a carbon double bond O and a hydrogen. So this is benzaldehyde here, and that benzaldehyde is an aldehyde. It's a type 2 carbonyl. Check, check. All of these are kind of falling in line. And this time we're going to add NH2, but this NH2 is not going to be connected to an R group. This NH2 is going to be connected to an OH group instead. Now, the reactions will continue very similar to what we've seen before. So let me show you how easy this is. Nothing new is being presented here. It's just a different group that it's bringing to the party, all right? So what you would have done in the past is you would have said, okay, Tracy, I know what to do. Here's my benzene, and there's my carbon, and there's my double bond O, and there's my hydrogen. And I know you told me over and over again that the oxygen's going to go bloop, 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 and we add on a nitrogen instead. Well, that nitrogen brings the buddies to the club. So basically everything other than hydrogen. So what is there other than hydrogen? It is a OH group that is there. All right, so this is typically what we have done in the past, except here the difference is that it's not an R group. It's not a carbon-containing group that it's bringing to the ring. This is an OH group that it's bringing to the ring, and that's perfectly fine. No one said that it couldn't do that. All right, well, this is OH. And this OH is called hydroxy. We now know that if we have to name it as part of another longer parent name. And this NH2 we now know as amine. So this is an example of the first one, folks. This reagent is called hydroxyl amine. So hydroxyl amine is a NH2OH. And that reagent has reacted with an aldehyde or ketone, and it does the same just like all of the other ones do. Nitrogen replaces the oxygen, and nitrogen brings the buddies to the club. And that's exactly what has happened here, all right? So there we go. We have a term that we use for this particular type of compound. It's called an oxime. I will probably never ask you what that is, right? It's just one of those things that we rarely see in Orgo 1 and Orgo 2, but this is a functional group, and that functional group does have a name, and we can name it and categorize it as a oxime because of that. All right, now let's look at number 2. And number 2 and number 3 is a 2,4-dinitrophenol hydrazine and a semi-carbazide. All right, so let's take a look at one of those examples. We'll do at least one of each one. All right, so let's do CH3, CH2, carbon, double bond O, and a hydrogen. So I'm going to use another aldehyde, perfectly fine, not a big deal. And I'm going to use 2,4-dinitrophenol hydrazine in order to react this thing with. All right, so what does that look like? Well, phenol, we know, is a benzene ring, and that benzene ring probably has a connector carbon to it, right? I mean, that was the difference between benzyl and phenol back in the day. All right, so phenol doesn't have anything connected to it. Benzyl does have something connected to it. Well, the name says this is phenol, so that probably means there is no middle carbon, and there is no middle carbon here. So this is a benzene ring, And off of this benzene ring, we have a 2,4-dinitro, and then the word hydrazine. So what is actually hydrazine? Well, this is a nitrogen with a hydrogen on it, and then another nitrogen, and this time 2 hydrogens added on to that one. Now let's take a look at the bonds of the nitrogen here. All right, I just want to count them up to make sure they make sense to you. This nitrogen that we see here, 2 hydrogens and connected to a nitrogen. There's a total of 3 bonds. That's why it's neutral. And then this nitrogen here, it's got a hydrogen bond, and then it has another bond to a nitrogen, and then it has a bond to the phenol ring or the benzene ring. All right, so that is a total of 3, and once again, that is why that is neutral. All right, now, we're not yet finished. This is just the hydrazine part of the phenol. There were other parts of the name too, right? It was called 2,4-dinitro. So if this is spot number 1, then that means this is spot number 2, and we have a nitro group, and this is spot number 3, and this is spot number 4. So at spot 4, we also have a nitro group. So 2,4-dinitro phenol hydrazine. That is the reaction. That's the reagent that we're going to be using here. So what on earth happens? Okay, well, this should be okay. You should already know the answer to that story. So what we're going to do is we're going to redraw the starting reagent, and here we are. That's what it looks like. And we're going to that oxygen away, and in that oxygen place, we are going to put the nitrogen-containing species. All right, well, that nitrogen is a double bond to the carbonyl, not the oxygen. But folks, this is the amine group right there, right? That's the NH2 group that we've always been working with. It's that nitrogen that is attached to the acyl carbon, and it brings all the buddies to the club. So what that means is that this nitrogen is going to bring with it the other nitrogen that is present that had the hydrogen on it, and that nitrogen was connected to this big, huge ring, and that ring had a NO2 group here and a NO2 group there. Folks, that is the product for that reaction. I know it seems uncomfortable. I know that it seems quite large, and it is, but the differences, not very many. It's still the same. It is a type 2 carbonyl reaction. This is an aldehyde that has reacted with a amine derivative, and that amine group is still an amine group, except instead of bringing carbons to the party, it's basically bringing this whole darn thing to the party. It's like a party crasher. You know, you say, hey, bring a friend, and then when they show up, there's like 20 of them that are there. You're not quite ready for it. So this molecule better be ready for it, because that nitrogen is bringing all of the peeps to the club. All right, so that was an example of 2,4-dinitro phenyl hydrazine, which is another amine derivative because we have formed an amine-related compound there. All right, so now let's take a look maybe at a ketone this time. We'll do a cyclohexane, and we'll do a ketone. I'll just draw it to the side to make it a little different. And then what we're going to react this one with is a NH2, and then an NH, and then a carbon double bond O, and then an NH2. So that's what we're going to do here. This is an example of what we would call a semi-carbazide. All right, so a semi-carbazide is just the classification of compound that this is, just like hydroxylamine, just like 2,4-dinitrophenylhydrazine. It's just a classification. And folks, this happens the same as all of the others. There's really no difference here. So the thing here, though, that you want to keep in mind is that there's two NH2 groups, and I think that this is probably what causes people problems sometimes, but you need to think of this. This is an amine reaction, right? And there is an NH2 group here, and there's an NH2 group there. So what I want to tell you is that those NH2 groups are not the same. No, they're not the same. And the reason that they're not the same is because this carbon double bond O is connected to the NH2. So this actually entire thing here is not an amine group. This is an amide group. And these are amine reactions. They are not amide reactions, are they? I have said nothing about amide reactions. I have only talked about an amine reaction. So here in this reaction, the same thing is going to happen. I just need to make sure that I'm picking the actual amine group in order for this thing to work. So this cyclohexane ring is there, a double bond O, and you're going to that oxygen away, and you're going to replace that with a nitrogen. It is the nitrogen of the amine that is going to go there. And that amine group is going to bring with it its friends, and that friend is a NH carbon double bond O with a NH2, and that is the proper lineup. All right, so that is the reaction of a semi-carbazide, and that is forming what we call a semi-carbazone, and that kind of stuff, again, is not very important. I'm probably not going to ask that for you, but at least you understand the basics are still there. It's still an amine reduction, folks. It's still an amine reduction. There's no difference, all right? Okay, so that kind of wraps up the formation of the amine and the enamine products. And after this, we've got maybe a handful of other reactions to talk about, but you're going to see that they react very similar to all of the ones that we have talked about before at this point. All right, so we are now done with amines. No more amine nucleophiles to make my organic chemistry lesson means. And we're going to pass on, and we're going to go on to what we call the reductive animation. So a little bit of nitrogen still there, but we can do something else to it in order to make a different product. So we're not focused on the amines, but it will be called reductive animation.